yesterday we learned about greatest common factors, and also called highest common factors, right? And we spoke about what factors are, and we learned a song as well. Can we sing the song? I'm prime, Prime. My factors are only one and me.
Factors that divide evenly. 2, 3, 5, 7, 11. Ooh, I'm prime.
All right, so that's it. And we also learned another song, prime. The prime numbers have only two factors. Composite numbers have more than two factors. Oh, prime numbers have only two factors. Composite numbers have more than two factors. 2 and 3 is prime. 4 and 6 is composite. 2 and 3 is prime. 4 and 6 is composite. Okay, so today we are trying to use another way of finding prime numbers, finding highest common factors and least common multiples using the prime factorization, or what we call the factor tree. Therefore, if you are given a number like this, 12, to find the factors of 12, and then so prime factorization. All right, so we have 12 and then we have 18. You could, like the previous way, you could just list the various factors and then compare. This time around, we could have something like this. Could have 12 and then expand it this way. What two numbers can you multiply to get 12? 2 and 6. All right. Okay, we'll represent the composite numbers with red. 2, 6. Right? Yes. But the 6, is it a prime number? No. It's not a prime number. Okay. So what two numbers can give us 6? 2 and 3. 2 and 3. Alright. Is 2 and 3 a prime number?
Yes.
Alright, so we could give it. Alright, so 2 and 3. Therefore, which numbers here are the prime numbers? Alright, so 2, 2, and then 3, right? So we could also write 12 to be the product of its prime. That means we are using just the prime numbers to find its product. That would be 2 times 2 times 3. Is that okay? Alright, let's try and see if we multiply this, we'll get a 12. What's 2 times 2? 4 times 3. So we got a 12. Is that okay? Alright, let's do the same for 18. 18. Factors of 18, that would be. No, which two numbers can give you 18?
2 and 9.
Alright, 2 and 9. Okay, which of them? 2 and 9. Which of them is a prime number?
9.
Which of them? 2. And which of them is composite?
9.
Alright, so we write our composite numbers with our red ink. Sorry, 2 and 9. So can we break this guy down further? 9. That will be 3 and 3. So these two are all prime. So we could circle them out and then have something like this. 2. Is that okay? Then if we are writing it, we would have this 2 times 3 times 3. Let's check it out if it agrees. What's 2 times 3? 6 times 3? 18. So what we have done here is that we have expressed these numbers as product of their prime. Is that okay? We have expressed the numbers as products of their primes. Now, how then do we find the highest common factor? The highest common factor will be the factors that they have in common. And those ones will be written as 1. Therefore, we have here, they share this 2, right? So you put them in a box like this. What else do they have? 3 and 3. All right. You say? 3 and 3. Yeah, so this pair, and this pair. This one, they don't have partners. There's a 2 here without a partner here. Is that okay? So we now write them as the highest common factor now becomes highest common factor or greatest common factor. I told you, when you see greatest common factor somewhere, don't say, oh, I don't know it. It's the same highest common factor. Is that okay? So the highest common factor becomes 2. So 2. All this is written as 1. Hello? So 2. And then 3. So what's the highest common factor of? Yeah, 3. This it's not added. The highest common factor are just the factors they have in common, the prime numbers they have in common. So they have 2 in common, and then they have 3 in common. So we just repeat the 2 and then the 3. Is that okay? Is that okay? All right. So it becomes 6. So the highest common factor of 12 and 18 is 6. Now let's try another one. Maybe 15 and 21. We would have to express 15 as a product of what? Product of its prime. Okay. So 15 becomes... Which 2 numbers can give me 15? Roy? 5 and 3, yeah. And interestingly, all 2 numbers are prime numbers, right? Yes. What about 21? Mary? 3 and 7. And interestingly, the 3 and the 7 are all what?
Prime numbers.
Are all prime numbers. So we could circle them like this. 1, 2, and then this. Right. Then we'll come and write it this way. 15 is equal to 3 times 5. Have you checked it out? You got the same thing. 21 becomes 3 times
7.
Alright, so what number do they have in common?
3.
Just this 3, right? So we just have to square them like that, and we'll have something like this. Is that okay? So this, the highest common factor, or is equal to 3. That's how we do it. Okay. So I'll give you some other examples. So take out your books. All right. Any question? Priscilla. You thought you'd multiply? No, we pick them as 1. We pick them as 1. Okay? Since it's here and here, you pick it as 1. Is that okay? So since it's here and here, you pick it as 1. Priscilla, are you okay? Yeah, so you pick it as 1. If it's here, you don't multiply. See them as they have combined, like they have entered each other, and it become 1. Is that okay? All right. Question? Okay. So that's it for. We'll learn other methods as well.